everyone. In this video, we're going to go over section 7.2 class note problems. So, first question is about a couple arrow diagrams for functions f and g. So we kind of need to determine, is this function one-to-one, onto, and bijective? Well, let's go with f first. As you can see, f is sending all the elements just to a single element on the other side. A is sent to t, B is sent to S, C is sent to W, D is to U, and E to B. So we have a one-to-one relationship in there. Also, it's going to be onto, because every element in the image has a single preimage here, has a preimage overall, so it's also onto. And so because it's one-to-one and onto, we have that, yes, it's going to be bijective. Now, for G, unfortunately, the function is not one-to-one. Notice that we're sending 1 to B and also 4 sent to B. So that makes it so it's not one-to-one. Onto, though, yes, the function is onto. The range is A, B, C, D. And every one of these elements has a preimage in here. And so it is onto, but because it's not one-to-one, then it's not going to be bijective. All right, question 2 says, using the function from the previous problem where f of a is equals t, f of b is equals s, so on and so forth, f of c w, f of d u, f of e b, explain what f is invertible but g is not. And so the reason why here is because it's a bijection. F is a bijection. Hence, f is invertible. I can actually define f to the minus 1 on the opposite direction. I can send S to B, I can send T to A, I can send U to D, I can send B to E, and W to C. So because of that, it's going to be invertible. Now, G is not one-to-one, right? And so because it's not one-to-one, it's not bijective, and it's not invertible. And one of the reasons is, like, for example, if you think sending a function from the here to here, you'll have to send B to 1 and also B to 4. And that's not going to be a function. That relationship is not going to be a function. So that's why G is not invertible. It's not invertible. All right, so f minus 1 as a set of order pairs will be the relationship, the backward relationship. So it will be S with B, T with A, U with D, B with E, and W with C. And so as an arrow diagram, you can just flip this direction and have a backwards here. It's not a lot to do here. You just flip the arrows and you'll have the direction here, f to the minus 1. Okay? All right. Now let's go, and once again, I did a spoke of this on the slides and the class notes and the introduction of the concept. We had this function g from c to c being by 4n minus 5. And I also can consider this from r to r being 4x minus 5. So we want to know if this is one-to-one and onto. And in both cases, the proof is pretty much the same. You assume that g of n1 is equals to g of n2 for n1 and 2 that belongs to the integers. And so it turns out that this is going to be 4n1 minus 5 equals 4n2 minus 5. And that means 4n1 is equals 4n2. And then n1 is equals n2. And with this, I can conclude that is 1 to 1. The same proof applies for this. It's just going to be now that x belongs to the real numbers. x1, x2 belongs to R. And so we're going to have that 4x1 minus 5 is equals 4x2 minus 5. And I'm going to arrive to x1 is equals to x2. Now, here in this case, G is onto, now G is not onto. And consider, let's say, 0 that belongs to the integers. So if M is so that G of M is equal 0, that implies that 4M minus 5 is equal 0, but that will mean that 4M is equals 5, or that M is 5 over 4. But this do not belong to the integers. So this means that it doesn't exist. There is no M for 0. So it's not onto. Even if I'm arriving on all the integers, I'm not covering all the integers. And so that's the reason why this function is not onto. And so is G invertible? No, because it's not onto. And that is the main reason in here. It's not a bijection. Now, for H, it's a little bit different. In here, since we're talking about real numbers, if Y is a real number, then you can think of X equals Y plus 5 over 4, which, by the way, is the inverse function. And when you plug H of X, that's just going to give you 4 times Y plus 5 over 4 minus 5, and that you can cancel here. You're going to get Y plus 5 minus 5, which is Y. So you found an X that matches any Y that you can pick. And so this is enough. And now, by the way, it is H invertible. The answer is yes. And H minus 1 is going to be precisely this. If you're wondering, how do we get H to the minus 1? Well, I just say, well, let's say Y is equals 4x minus 5. And now I'm going to just flip this, and I'm going to interchange x by y. And I'm going to solve for y. And so if I solve for y, I get x plus 5 is equals 4y, or x plus 5 over 4 is equals y. And this is just going to be my f minus 1 of x. I just found the opposite function here. Now, you can kind of verify that f minus 1 compose f is equals x, and you can verify that f compose f minus 1 of x is equal x. And this is something that, once again, we went over the slides, but this is essentially one of the directions is this. If I'm doing f compose f minus 1, f compose f minus 1 of x, it will just be 4 x minus 5 over 4 minus 5, which you know is x. And if I'm doing the other direction, if I'm doing f minus 1, it will be f of x plus 5 over 4, which is like 4x minus 5 plus 5 over 4, which is once again 4x over x over 4, which is x as well. All right, so this is just a reminder of what we saw on the slides. But now let's follow with a couple different functions to see if this is going to work out in the same way. So number 5 is, for each of the following functions, determine without a formal proof whether this is one-to-one, onto, both, or neither. So we have f from the real numbers, 3x plus 1. Yeah, this is going to be one-to-one. It's going to be onto as well. And so because it's both, then we're good. For the integers, then the answer is no. It's probably going to be 1 to 1, but not onto. Same reasons as the ones that we use here. So that's why we had this reminder, so we can understand that when we have from integers to integers, there's a big condition in there. You can probably figure out that 2 is on the integers on this side, but there's not going to be element here that matches this, because n will have to be 1/3, and that doesn't belong to the integers. X squared minus 4 from the real numbers to the real numbers. This is neither not 1 to 1 and not onto. Why? Notice that this is a parabola. If you think about it, x squared minus 4 is just like this. Here minus 4. So for any value of x, for any value of y, sorry, you're going to be getting two values of x that are related. So that's not going to make it 1 to 1. And it's not onto because you're not going to have all possible values. Like, for example, you can see that this only reach up to minus 4. But if you get like minus 5, you're not going to have elements that works out with that. Like, there is no x. So f of x is equals 5. And 5 is a real number. And this really is because if x squared minus 4 is equals 5, 5, well, let's try with minus 5 instead. No, sorry, not 5, minus 5. If I get minus 5 in here, then you will get x squared is equals minus 1. And so that's impossible, as we described before. So that's what it makes it no onto, minus 5. With x squared from the real numbers 0 to infinity is an entire different matter. The codomain is 0 to infinity, not all the real numbers. And if we go from f of x equals x squared, it's like we're only taking half of this. So f of minus 1 is equals f of 1 here, which is 1. So this is definitely not 1 to 1. Okay? Now, is onto because you can take all the values from 0 to infinity. I don't need to go further than that. And if I do f of 0 is 0, and then from there onward, so this is going to be for any value, for any y, f of a square root of y is going to give you y. So that works for any y that belongs from 0 to infinity. Okay? So that's going to give me the value that I need. Now for question number 6, we have f from a, b, c, d, e, and to 1, 2, 3, 4, 5. F of a is to 3, f of b is to 1, f of c is to 4, f of 2d is to 2, and f of e is to 5. Is f 1 to 1? Yes. You can notice that the outputs are 3, 1, 2, 4, 4 to 5, which are all distinct. If it's onto, yes. The range, which is equals to the codomain, is hit. So every single one of them is going to be hit. Because if it's bijective, then yes. And is it invertible? Yes. Why? Because I can just go with the inverse function going backwards from each of these elements to the original. So the f minus 1 will be what? Well, we'll be going the opposite way. We will have 3a. We will have 1b. We will have 4c. We will have 2d. And we will have 5e. That'll be the inverse function. And so in terms of our diagram, then you can build this out. You can fill 1, 2, 3, 4, 5. And then you can have A, B, C, D, and E. So 3 to A, 1 to B, 4 to C, 2 to D, and 5 to E. And that'll be the arrow diagram. All right, we'll continue this in part 2.